Welcome to the next module. In this module, we will be looking at Arctic cryosphere and glacier change mechanism. So let us look at what are the components of cryosphere. There are various components. The first one is snow, then we have permafrost, river and lake ice, mountain glaciers and ice caps, Greenland ice sheet and sea ice. Since we are talking about Arctic, we have included Greenland ice sheet also. So in the snow, this is mainly formed by the solid precipitation, and when we talk about permafrost, it has subsea marine environments. This is also having terrestrial environment and soil at or below 0 degree for the 2+ years. Then those type of soils are generally called as permafrost, that means permanently frost soils. And in the sea ice, we have first year ice, multi-year ice and land fast ice. We will look at the different types of ice in the later part of the series. So why we have to study about the cryosphere, especially the Arctic cryospheres? We are just going to look at what are the importance of the Arctic cryospheres. The first one is, if we know the energy balance. Why we need to know the energy balance? We can understand how it affects the net cooling effect of Earth's surface, because Arctic is actually in the northern hemisphere, although it is far off from in the polar region. Still it affects the entire globe. So that's the reason, by knowing the energy balance in the Arctic, we can understand how it affects the cooling effect of the entire Earth. Then we can also learn about global circulation. So how it affects the global circulation? This influences the air and ocean circulation. The Arctic cryosphere actually affects the global circulation of air. Not only air, even water also getting affected because of Arctic cryosphere. And we also have the freshwater storage, which is the major component in the Arctic region. So this is seasonal to millennial scale. It actually increases the water level and it regulates the freshwater availability in the entire region, and also it affects the sea level. So these are all the major contributions from the Arctic cryosphere. And when we talk about the land mass, this determines the surface available for habitation. So that is how we can understand how the Arctic cryosphere affects the Arctic region. And also when we talk about the greenhouse gases, it regulates the storage and release of carbon dioxide. And also it includes methane and carbon dioxide are the major greenhouse gases. So the Arctic cryosphere controls the storage and release of these greenhouse gases. We will look at the various mechanisms by which how it operates in the later part of this course. Now, why we talk about Arctic? The main reason why we talk about Arctic is, like we had seen, the Arctic amplification. That means Arctic area gets heated up more than the global average. So these are some of the events which are happening very recently. So let us look at a little bit more about what are the recent Arctic changes. So the temperature trends, when we look at in the past decade, the highest temperature in instrumental records, that means Arctic recorded the highest temperature, and also the current summer temperatures are higher than the past 2000 years. So this is the major thing we are observing in the Arctic. So these are all the recent changes that are occurring in the Arctic. And the very purpose why we are going to know this is, by knowing this, we are trying to understand how the Arctic cryosphere is affected by this recent change, and also how the Arctic cryosphere affects the global environment and the climate. The next one is the ocean heat storage. So in the ocean heat storage, what is happening recently is there is enhanced heat flows. This is from the North Atlantic and North Pacific. More heat water is entering the Arctic region. Because of the hot water, what happens is the sea ice becomes free. That means the ice in the sea becomes reduced and we have more open waters. So this leads to a positive feedback. In other words, like more open water leads to more heat storage. Because we have seen the temperature trends which are just happening above the sea level, and ocean heat storage is occurring at the sea. Now we are going to see the atmospheric effect, which is much higher than the sea level. So cryosphere generally exists at the ground level, but this also affects the atmosphere. So how does it affect is basically the autumn temperatures are affected. That means increase the influence of atmospheric temperature. So because of the Arctic amplification, the gases are getting warmed up. The surface air temperature increases, which increases the atmospheric temperature also. And wind fields also are getting affected. That means it changes consistent with the increased cloudiness. So that means both the wind direction and the wind movement is also affected because of the change in atmospheric temperature in the Arctic region. We are going to look at some of the feedback mechanism, that is sea ice and the temperature feedback, how it happens in the Arctic cryosphere. So the feedback emergence was actually first detected in 2015 AICA reports. That's the first time we had seen that there is a feedback mechanism that operates between sea ice and the temperature. Then storms and extreme temperatures are increasing in frequency and intensity. So this is observed very recently. The temperature increases and also we have heat wave events are happening very regularly, and their intensity as well as the frequency had increased. And when we look at the precipitation actually changes. In the recent decade, what we have seen is large year-to-year variability is actually seen, and also it is increased by around 5% since 1950. Earlier there were only snow in the Arctic region, but now because of the increase in the temperature, the snow is now melting. When it falls as a snow, then it is getting converted into water, in other words rain. So the snowfall is getting converted to the rain. So this is what is happening in the recent years. And also there are some other natural variabilities. That means how it is going to affect the future. The difference from smooth average due to natural variability is actually we are seeing. And also some example is like in 2007, the sea ice loss greater than the most GCM projection, that is global climate model, had predicted how much sea ice is going to change, but in 2007 there was an abnormally, that means lots of ice had changed. So these are all the various effects that are happening in the Arctic region. So when we talk about the warming or the precipitation, so there is a widespread warming and increase in winter precipitation over the past 40 to 50 years. That means this is what is the major change, because temperature increases, snow gets converted to water. That means instead of snowfall, we are getting rain. Precipitation is happening in the Arctic region. And what are the regional responses that is happening? That is the largest decrease in the snow water equivalent and snow cover duration in maritime regions that we are observing. And there is a prolonged decrease in the North American sector, and also increasing snow depth in many Eurasian regions. There is a change in the snowpack structure due to warming and frequent winter thaws. So these are all the regional responses that are being seen or observed. When there is a snow cover change, what are the consequences? That means when there is a change in the cryosphere in the Arctic region, what it leads to? That's what we are going to see. It is going to change the climate system. So how it affects the climate system? So it influences the surface energy balance. That means when there is more ice, then the albedo is more, that means more of the sunlights are reflected. But when there is less ice, more of the sunlight is being absorbed. So that means there is a surface energy balance is getting affected because of the change in the ice. That means the cryosphere, if it loses more ice, then that leads to a change in the climate system. And also the water balance, that means storage and release. When the temperature increases, more ice is getting melted. So that means the input of water increases. In other words, the water balance keeps changing. And also thermal regimes, that is insulation, changes quite a bit. And vegetation also is getting affected, and also trace gas fluxes are also changing. So these are all the climate effects that are happening due to change in the cryosphere. And if you look at the biogeochemical cycle and hydrology, it impacts the climate system and water cycles. In the later part of the series, we will be looking these effects in a much more detailed way. Then we have the ecology and the human well-being. So here the impact of Arctic resident and services happens because of cryosphere change. So when there is less ice and more of water, that actually the people in the Arctic region, that is the Inuits, they survive basically on the hunting. So when the sea ice melts, the probability of getting the seal or other type of sea mammals gets reduced because they go away from the ice area and they go to the area where they can hunt. So that's the reason when these animals are no longer to be seen near the Arctic region. So winter thaw and rain on snow affects the commercial forestry and reindeer herding, and also the potential benefit for hydropower industry due to stable snowmelt runoff. So this has both positive and negative effect. Positive effect leads to more water, means it can lead to hydropower industries, that means they can produce more electricity, so that is the positive effect. But the negative effect is change of vegetation, which leads to change of reindeer herding, which leads to difficulty for the local population. And also some of the negative impact include compromised health of Arctic residents and also the challenges for commercial forestry and reindeer herding. So these are some of the negative impact, and the potential benefit, as we say, the more runoff leads to hydropower industry. Here is a variability of total precipitation during the cold season, that is from October to May, when mean monthly temperature is below -2 degrees centigrade for inland stations. This study was carried out for a long time, that is from 1936 to 2009, and also for a short term from 1980 to 2009. The linear trends are actually seen. So here is the various places. Each dot refers one of the place in the Arctic region, and the names, if you see, this is Alaska, this is Chukchi Sea area, this is East Siberian area, and this is the Canadian archipelago. And these are all the different places, and all these places have different types of precipitation, and this is being monitored for over 30 or 40 years. So these are all the trends we are actually seeing. So the red line here indicates that a positive trend, and the dark blue line, if you look at these lines which are going up and down, are the negative trend. The red lines are actually showing a positive trend which can be seen very easily. And in the Chukchi area we have the dark blue line. So this is where the trend is actually having a negative trend. And this is the Atlantic region. Here you see there is a little bit negative trend, but most of the year this is actually the red line which is the positive trend. And the rest of the areas it is mainly the red line which is the positive trend that is actually happening. And results for Canada used and the adjusted homogenized precipitation data sets of Meekes and Hogg updated to 2008. So there is a paper which actually talks about this one. This is basically from the Arctic Monitoring and Assessment Program 2011, snow, water, ice and permafrost in the Arctic. So that is what they have actually done, thorough study, and they have given this particular observation. And similarly here is another area which occurs like it's again the long-term variability in the total precipitation during the cold season. So here the marginal Arctic area, Central Arctic Basin and the Northern Territories of Canadian archipelago are actually seen. Here again we see the similar trend.